Today we're on page 5 of our Chapter 16 notes packet, Section 4, Probability of one event with two outcomes. So you're going to be introduced to a formula here that you're going to have to memorize. For a given event, if the probability of success is denoted by lowercase p and the probability of failure denoted by lowercase q. Now keep in mind that p plus q would equal 1, or in other words, we can state that q would equal 1 minus p. Then the probability of exactly r successes in n independent trials is given by this formula. NCR, P to the R, Q to the N minus R, where N is the number of trials or tosses or attempts. Like if we're looking at tossing a fair coin or attempts at a basket. R is the number of successes. Lowercase p is the probability of success. And lowercase q is the probability of failure. So in other words, if the probability of success is 1/5, the probability of failure would be 4/5. So we're going to work through these examples here. The first three, we have a fair coin is tossed 3 times. A fair coin is being tossed 3 times. So n is 3. Find the probability of getting A, exactly 2 heads. All right, so off to the side here, I'm going to write down our n is 3, r, the number of successes, or the number of heads in this case that we're looking for, is exactly 2. So r is 2. The probability of rolling ahead, or the coin coming up ahead, lowercase p, is 1/2. And then the probability of failure, or that it doesn't land up heads, is also 1/2. Okay. Okay. So this is the first time seeing the formula, so let's write it down. This is going to be NCR, P to the R, Q to the N minus R. N is 3, so 3, C2. Our probability P is 1/2 raised to the R squared, and Q 1/2 raised to the 3 minus 2, which is 1. Now we can key this whole thing into the calculator. I don't mind working with fractions, and because, well, before we had the TI-84 calculators, we had to figure 3 choose 2 out by hand. And I know that just from years of experience that 3 choose 2 is going to be 3. So this is going to be 3. And I don't mind fractions when they're small like this, right? 1/2 squared, that's 1/2 times 1/2 is 1/4. Times, and remember this is all multiplication between here. It's 3 choose 2 times 1/2 squared times 1/2 raised to the first, which is going to be that's a half. Sorry, I put a 3. 3/8. And we can key it into the calculator just as it is. 3 math, probability, number 3. So 3 choose 2 times 1/2 squared. I'm going to put it in as 0.5 squared times 0.5 to the first. And it gives me this decimal, and if I math frac, and again, decimal answers are acceptable. 3/8. So 3/8, or we can write the decimal equivalent 0.375. Part B, we want exactly 3 heads. Find the probability of getting exactly 3 heads. So our n is the same, all right? The fair coin is being tossed 3 times, so n is going to equal 3 for parts A, B, and C. Exactly 3 heads, the 3 heads, that's our R value now. So R is 3, and our lowercase p is going to remain 1/2 and lowercase q 1/2. So we just plug into the formula. N choose R, so 3 choose 3, lowercase p is 1/2 raised to the R power, which is 3, R is 3, and q, which is 1/2 raised to the 3 minus 3, or 0. Your exponents here are always going to add up to your n value, right? 3 choose 3, I know is 1. 1/2 cubed is 1/8, and 1/2 raised to the 0 is 1. Again, you don't have to work this out by hand. You can just key this all into the calculator, but as I said, I have a harder time, or it takes me longer to key it into the calculator than it is to work it out by hand. So this is equivalent to 1/8. C, exactly 1 tail. Find the probability of getting exactly 1 tail. All right, so n is 3. Now, the number of successes is 1 tail. Now, the probability of success, the probability of getting a tail, now remember, we switched from heads to tails. Well, the probability of getting a tail when tossing a coin is still 1/2. And the probability it's not a tail, the probability of failure, the Q value, is 1/2. Let me write the formula again. I didn't do that in the last one. So that's NCR, P to the R, Q to the N minus R. Again, you have to memorize this. So this is going to be 3C1. P is 1/2 to the R, which is 1. Q, which is also 1/2 to the N minus R, 3 minus 1, which is 2. All right, I'll go to the calculator and key this in. So 3, math, probability, number 3 for NCR, 1 times, I'm going to do 0.5 to the first is simply 0.5 times 0.5 raised to the 3 minus 1, 0.375. So this also is 3/8. Our next example, we're looking at a die is rolled 4 times. So right away, a die is rolled 4 times, so our n value is 4. What is the probability of getting A exactly 2 3s? So n is 4. The number of successes, R, is 2. The probability of success, lowercase p, is when you roll a die, what is the probability that you get a 3? It's 1 out of 6. So the probability of failure, the Q value, would be 1 minus 1/6, or 6/6 minus 1/6, which is 5/6. Your P plus your Q value would always add to 1. Okay, so NCR, P to the R, Q to the N minus R. NCR, P to the R, Q to the N minus R. For C2, our P value is 1/6, our R value is 2, and our Q is 5/6, raised to the N minus R, 4 minus 2, which is 2. All right, I'll go to the calculator with these fractions. So for math, probability, number 3, 4 choose 2 times 1/6. I got to put in the fraction. Alpha y equals 1/6 squared times 5/6. (25 over 216). Part B, what is the probability of getting all 5s? All 5s. Now the die is being rolled 4 times, so we mean what's the probability of getting 4 5s? All right, N is still 4. We're looking for how many successes? 4. So R is 4. Now our probability, what's the probability of rolling a 5 on a die? It's 1 out of 6. And then the probability that it's not a 5, probability of failure is 5/6. So plugging in 4, choose 4, P 1/6 raised to the R 4, and then Q 5/6 raised to the 4 minus 4, or 0. Okay, keying this into the calculator. I'm going to try this. I'm going to do the second enter to bring back up what I had in there. And I'm changing the power on the 5/6 to 0. And the power on the 1/5 to 4. And the 4 choose 2 to 4 choose 4. That should be correct. 1/1296. And C is asking for the probability of getting no 5s. So 0 5s. Number of times it's rolled, it's still 4. Number of successes we're looking for, our R value is 0. Probability of getting a 5 is 1/6, and the probability of failure that it's not a 5 is 5/6. And now we substitute these values into our formula above. NCR, so 4C0, P 1/6 to the R 0, and Q 5/6 to the N minus R, 4 minus 0, which is 4. I'm just so tempted to do this by hand again. I know 4 choose 0 is 1, 1/6 is 0 is 1, so it's simply going to be 5/6 to the power of 4. Okay, so I'm just going to use the calculator because that's what I know you would do. You're not familiar with 4 choose 0 and okay, I believe it's keyed in correctly. 625 over 1,296. All right, and we'll save 3 and 4 for in class. That's our lesson for today. Thank you.